Okay, today we're going to talk about wave interactions. And these are ways that waves can kind of come together to do certain things, or ways that waves can interact with the environment around them. There are 5 main types I want to touch on today. So the first thing we need to know about is reflection. Now you guys are very familiar with this. Whenever you look in a mirror, you see something reflected back at you. That is a reflection. Now this diagram shows us what is happening with reflection. So you have to have some kind of an opaque surface, or when we talk about light. But you could also have a mechanical wave. Think about if you throw a basketball down and it bounces back up. That's a type of reflection because it is reflecting kinetic energy. So one thing I want to point out is this. This I here and this R here. The I is the incidence. This is what you're causing to happen. Now this could be you shining a flashlight against a wall, or it could be bouncing a basketball, whatever. If you come in at this angle, it's going to reflect at the same angle. So let's say this angle is about 20 or 30 degrees. From here to here, if that is 30 degrees, then this angle right here has to also be 30 degrees. The angle of incidence, the angle of reflection. All kinds of waves can reflect. Like I said, mechanical waves and electromagnetic waves. So what I just said to you is actually called the law of reflection. The law of reflection states that the angle of incidence, that's where the angle occurs, where the reflection begins to happen, is equivalent to the angle of reflection. Again, the angle of incidence is equivalent to the angle of reflection. Looking at that diagram again, this angle is equivalent to that angle. That is all that it is saying. Next we have refraction. And refraction is going to be the bending of a wave as it passes through different media. So what's going to happen is, because you have different densities of media, as they go through one type to another type, it's going to change the speed. Now for an electromagnetic wave, or visible light specifically, it's going to appear to be different from us, from what we observe. So if you look at the fish in the tank, direct from the eye to the fish is a straight line. However, it's going to bend slightly, and you're going to see the fish looking quite different to your eye. Let's look here. I'll show you what I'm talking about. So here we have the old pencil in the glass of water. Here we have a straw in a glass of water. As you look at this, you can see it does look different. It doesn't look like it matches up. Looks like it's actually severed. This part looks a little bigger than that part. So what's happening here is the visible light is traveling through water, which slows it down because it has greater density, and it's traveling faster through the air. Because you have 2 different speeds, that is going to bend. All right, so again, refraction is defined as the bending of a wave as it passes through different media. There's also another way that a wave can bend. That is called diffraction. So it sounds a lot like refraction. But this is a bending of a wave around a barrier or through an opening. Also note that lower frequency waves diffract more. This is why when someone has a deeper voice, you can hear them through a door much easier than you can a person with a higher voice. But let's look at some examples of what we're talking about here. One thing I want to say is this. Lower frequency waves are going to experience greater diffraction than higher frequency. So if you look here, you can see that the size of a barrier is also going to affect the diffraction. As this moves through, because you have a much larger space for it to go through, it can actually spread out more. Here, because you have a narrow opening, it cannot spread out as much. And if you look at what happens when you have multiple openings, the waves can kind of interfere in certain places. One other way that we can have diffraction is around a barrier, and you can see the light or the sound, whatever it is moving, is actually going to bend around this barrier that's right here. So again, diffraction is going to be the bending of a wave around a barrier or opening. 2 other types of interactions we have. We have what we call constructive interference. Constructive interference is going to occur when you have 2 waves that come together to make a larger wave. So here we have wave A and wave B, and when they come into contact, it makes a very large wave that's actually this amplitude plus that amplitude. Once that interference is over, they'll kind of keep going in their own direction, and they will split apart. Another way to kind of conceptualize constructive interference, this plus this equals the wave this twice the size essentially. You're combining the amplitude, you're constructing the amplitude to have a much larger wave. And then we have destructive interference. Destructive interference is the opposite. What you're destructing or deconstructing is going to be the amplitude of the wave. So you have this and that to come together, and if you'll notice, these are opposites. Where you see the crest here, you see the trough in that place. And it kind of, it is opposite of each other. So what happens is, this kind of falls here and this kind of falls here, and it results in this flat line, which means no amplitude or no wave at all. It's just the rest position. So the destructive interference is the crest of one wave flows into the trough of another wave, and the resultant combined wave is smaller, or in this case, doesn't even exist. Another way to kind of compare the two, constructive, if you add the blue plus the yellow, you get the red wave, which is much greater. Here, blue plus a yellow equals no wave at all. The amplitude is decreased. So again, you can see how the crest here and the trough here, they're in the same position, so they kind of destroy each other. Whereas here, they combine. All right? So go ahead, complete your fever form. If you do have questions, let me know, and I'll do the best I can to help you. Thank you.